Hello and welcome to the session on partial fractions. When we're dealing with solving a differential equation, we can basically use Laplace transforms to solve the differential equation. And once you use Laplace transforms to solve the differential equation, you will come across a situation where you'll probably require to use partial fractions. So what exactly is partial fractions? We can resolve the following into partial fractions. What do we mean by that? S plus 4 divided by this denominator can be written as a over s plus b over s minus 1 plus cs plus d over s square plus 4. Notice that when the denominators are quadratic, we write it as cs plus d. This is something which is basically mentioned in the PDF that is put up on the web page on WordPress, and it would be good if you'll go through it, and that's when you will understand all of this. Taking the LCM, we get the following. You will see that the left-hand side equal to right-hand side. The denominators are the same, for which we can equate the numerators, and we will see that we get nothing but equation 2. Now, in equation 2, we would like to substitute and get values for a, b, c, and d. So what I'm going to do right now is I'm going to plug in the value of s equal to 0 into equation 2, and I will get a as equal to minus 1. On plugging the value of s equal to 1 into equation 2, I will get b as 1. Equating the coefficients on both the sides of 2 will basically help us to get the values of c as well as d. Coefficients of s cube on the left hand side is 0, and when you equate it to the right hand side, you get a plus b plus c is equal to 0. Plugging in a as minus 1 and b as 1, you get c as 0. Coefficient of s square is 0. The coefficient of s is equal to 1. Equating it to the right hand side, you'll get the following. Plugging in the value of a is equal to 1, minus 1 and b is 1, you get d as minus 1. Once we have attained the values of a, b, c and d, we plug it back into equation 1 and we get the following. And you see out here, equation 4 is such that the following has been resolved into partial fractions. It is once that you resolve into partial fractions that it gets easier to actually find the Laplace transform of the following functions. So as practice, this is an assignment that's given to you. There's a submission date for which you will have to submit on Moodle. Kindly do the same and submit the assignment within the deadline given. That will be all for now. Thank you.